Okay. So this is known as a box plot or box and whisker plot. So, like the question says, what do you notice? What do you notice about this graph at all? Is there any information you could obtain from that? There is a box, yes. Morgan, what were you going to say?
That the line is like, it's probably like 28, maybe. The line, that's 28, the middle line in the box.
This line right here?
Yeah.
28?
I mean, sorry, like 18.
Which line are we talking about?
Oh, yeah, like 23. Sorry, I read it wrong.
Okay, so we're talking about this line maybe? Yes? Morgan, you talking about that line? So she's saying that's maybe about 23. Does anybody know what that line represents? Yes, that is the median. What does median mean again when we're talking about data and statistics? The middle. So right there, that is the middle point of data. Exactly half of the data is to the right and half of the data is to the left. Now, when you look at it, you're like, well, that's not in the middle. Well, that's because the data isn't exactly in the middle itself. Okay, it's not at 50 where we have half of it this way and half of it this way. All right. What else do you notice?
Those, is that the left side or right side?
Well, are you talking about the right or the left? I don't know.
So the left side is like this smaller than the other one because the right one is really long.
Okay, so this, are you talking about from the median or are you talking about from the end of the box? Are you talking in this direction? Okay, what about that?
It's like longer than the left side.
It is definitely a lot longer, yes. Do you know anything about those two amounts? What if I told you, CJ, that 25% of the data is located in that area from the end of the box all the way to the right? And what if I told you 25% of all of the data was also at the far left of the box all the way over to the left? Okay. Would you believe me? I hope so. Usually when we look at this, we were like, oh, well, there must be a whole bunch of people that scored between, say, 36 and 90. But this is the spread of data, okay? A box and whisker plot or a box plot talks about the spread of data, how far out it is spread. Okay. What is Herlin? You not so. Question: are you going by Schneider these days or Herlin? Okay, because you're signing everything Schneider. It totally messed me up. So, what did you say about the maximum score? Yeah, 90. This is the maximum score that someone actually got. What about the minimum score? 0. Okay, so the minimum score, what could they have scored? What's the highest they could have scored? No, someone did get 90, but what's the maximum they could have gotten? Gabe, put the phone away. Yeah, you could have scored 100. No one scored 100. The highest score was a 90. And notice this does say scores down here. So these are all scores. We don't know scores to what. Okay. What else do you notice? So what does the box represent? Isaiah, what do you think?
The amount of students like took the test.
Not all of them. 25% of them who took the test or whatever it was are to the left of the box, and 25% are to the right of the box. So what does that leave the box to hold? What percent? Morgan. What percent does the box hold? If 25 is to the left and 25 is to the right, yeah, this is the middle 50%. Okay? And from here to here, this is 25%. And then from the edge of that box to the median, this is also 25%. So, if I said 75% of the students scored what amount or less? 75% of the students scored what score or less? About. 75% of the students scored what on this test, if this was for a test? No? Yeah. If I look at this, they must have scored about a 36. So 36 out of 100. So was this a hard test or an easy test for the class? Really hard, really hard. 75% scored a 36 or less on this test. Okay. We already said that's the maximum, the minimum. We said the median. This amount right here, which is halfway between the upper half of data, this is called the upper extreme or the upper quartile. No. I'm getting things messed up. It is the upper quartile, or it is sometimes called the third quartile. Yes. And halfway between the bottom half of data, this right here, yes, is called the lower quartile, which is basically the middle of the lower half of data, and or quartile 1. Okay? So the big thing you need to remember here is that a box plot shows how spread out things are. It's divided into 4 sections where the amount of data in each section is the same. Okay? All right, let's take a look at this one then. So here we have a box plot. What can you tell me about the box plot right away? Is this the same exact one? Okay. Same exact one. So we have a minimum score of 0, a maximum score of 90. Our median, we said, was maybe 24, 23, somewhere in there. That's our median. Okay. These are frequency graphs. Okay. They tell you how much data falls in that area. So with this box plot, if I were to, let me expand this a little bit. If I were to try to find middle and the median for frequency graph B, the middle, where half of the data is to the right and half of the data is to the left. Damari, take a look up here. Frequency graph B, where am I going to put the median? Is it going to be over here? Does this look like These match? No, that's not half. Where would I put that median so I have about half data to the right and half data to the left? Yeah.
At the top point of the graph,
At the what?
at the sharp top point.
Okay, maybe about here. All right, so that maybe is the median. So does this frequency graph match up with our box plot?
Wait, no.
Because this is about 35 and this is about 24. So this one isn't going to match up. Okay. Look at these other two. Let's look at this one. Where do you find about half the data to the right and half the data to the left?
Oh,
It's what? 15?
no, it's
Group
group C.
C?
I mean,
Okay, well, let's talk about graph A first. Where do you see? Okay, I can't even see. Can you move your bag down or to the side? Where would I put this to be about halfway? And how could I tell? Okay, if I put it right there, how can I tell that half is to the right and half is to the left? Couldn't I count the areas over here of the boxes? Well, that's one whole box. Here's almost 2 boxes. Here's 3.
it's not.
Here, this one, and maybe this one together would make 4. And maybe this would be 5. So I have almost 5 complete boxes plus a little bit more, right? If I look over on the left-hand side, I've got 1 complete box here, maybe 2 with this and a little bit more, and maybe 3 here. So I need to move that median where? To the right or to the left to make it more 50-50? I need to move it a little bit more to the right. Okay, so that takes some of this area off. This is going to take away some area. And this is going to, by moving that, add some area. So now my median, if I move it to the right, is about at what? If this was 20 right here, this is about 22, 23. Do you think that picture matches up with this box plot? Okay, before we answer, let's take a look at the bottom one. Whereabouts would you put the median for this bottom graph? Maybe here?
No.
Would you go farther to the right?
Yeah, but like, but that's like in like
Yeah, that's in the 30s. Is that going to be closer to the median?
no.
Or is graph A?
What's graph
Graph A right here.
graph
So that is about 22, 23. So graph A wins, okay? All right, so here's what's going to be happening. I'm going to give you a set of cards. You are going to take turns trying to put the box plots together with the frequency graphs, okay? So the box plots, I want you to put 1, 2, 3, 4, 5, 6, 7, 8 all the way down. And then you are going to match up the frequency graphs. Now there is a third category, but we're not going to worry about that tomorrow unless you get all of them correct today. Okay? And with about 5 minutes to go, I need for